We're going to start off with our math routine on slide 6. This comes from Robert Kemplinski. He's the creator. Dan Schuster has adapted everything to Google Slides. So if you're looking for a Google Slides version, there are 3 links on slide 6 for you to investigate some more. And the protocol that I'm going to implement is on slide 7. I like to be very transparent about my teacher moves. Many of these things are done in the face-to-face class, and this is how I'm going to optimize the advantages of the technology in the online. So first here, you're going to move it, which means you're going to move numbers to make the statement true. Here's an online part. We're going to generalize it. So if you ever hear things like, hey, you have to double, you have to do this, you can't use this, as soon as that thought comes to your mind, type it right here in the chat box, and we're going to have these like ideas rolling through as you're trying things out. If you find one that works, for example, slide 8, you're going to leave the numbers there, move your star over, give yourself credit by putting your name in the star, and you'll make a duplicate slide and keep trying for more and more solutions. That way we can see lots of completed ones. And then at the end, we're going to share it over the microphone. So without further ado, go ahead, grab a slide. You can put your name in the star already. That's how you can show that you're reserving that slide for you. And play around. Move those numbers in to make this statement true. Using the digits 0 through 9 at most once each time, fill the boxes so that the one rectangle is a scaled drawing of the other. And again, feel free to put your name in the star already to reserve that slide. Hello and welcome. If you're just joining us, here's the link to our slides, and we're trying out the open middle problems. You can find a space on slide 28. There is room for you. Hi, Aisha. Welcome.
Thank you.
If you want to head down to slide 28 or 29, nobody's on those. You're going to move those numbers into the dotted lines in order to make this so that one rectangle is a scaled drawing of the other. And keep trying. This is all about trying something, going back, trying again. And if you have any generalizations, please put them in the chat box. What are you noticing that you can't use or you always must use? Hello and welcome. If you're just joining us, the link for our slides are in the chat box. You can come on down to slide 29 and try the open middle problem where you move those numbers into the blanks to make a scaled drawing. And at this point, I'm going to ask a couple of us to share, and we're going to start off with Rachel's comment that just came in the chat box. Rachel's work is on slide 12 if you want to join us. I've also got it displayed in Collaborate. You mentioned here that you cannot use a scale factor of 1 or 2. Can you elaborate a little bit on this generalization?
Sure. So I realized that the smallest scale factor has to be 3 because you have 1 digits on the smaller rectangle and 2 on the other, and you can only use the digit 1 time. So if I had like 6 times 2, for example, that would be 12, and then I'm using the digit 1. But then the largest single digit number here is 9, and that times 2 is 18, so you can't use it twice.
Ooh, what a great generalization, Rachel. Thank you. And did that help you to come up with your work on slide 12?
No, that I did first. I was like, all right, I'll just times by 3 first. I don't know why I just picked a number. And then I was trying to do another one. I lost my slide somewhere in the mix, so it's definitely an incomplete one somewhere. And I realized that afterwards because I was trying to come up, there it might be. I was trying to come up with another idea.
Very cool. Yeah, so these ideas will help us be more efficient in solving them. Joyce, why can't you use a factor of 5?
I believe because the repetition of the pattern are ending 0505. So when you every time you try to put a number, you're either going to get the 5 back or you're going to use it and you don't have enough. The numbers repeat. Just at the end of 5 or 0. Thank you.
So now there's something special about that 0 and 5, and you've definitely noticed it here. But I want to bring to our attention slide 28. And Laura also brings this up. So Joyce and Laura or anyone else, can you make sense of why 28 works, but what is still weird about 0 and 5? Because you're right there with it. 0 and 5 have something going on with it. So let's try out a couple things to see what changes. I'm going to take this 4. Lydia, I'm going to make a duplicate copy just so you don't lose your original work. It's below it. Lisa, go ahead and talk to us. I'm going to put some numbers kind of up here for you to explain what you just noticed.
I think that was maybe Lydia's slide that we were using, and she had a 3 and a 4. So if we use that scale factor of 5, because 3 is an odd, we'll have a value that ends with 5, and 4 was even, we'll have a value that ends with 0. So we'll definitely need one odd and one even for that to work.
Ah. So the 3 is odd. It gives us a ones place of 5. The 4 was even. If you want to test it out, check it out. Try some other even numbers and see if that holds true. All right, folks, so this is just a brief example of how we can use open middle as a warm-up. I stayed within my time limit that I wanted to do there, but also we had some really rich generalizations here about the 5 and the 0. And in one day, that might be all I do for a routine. In other days, I'm going to keep bringing this up and having more and more and more generalizations come out of it. So again, the protocol that I used is on slide 7, where you move it, you generalize it in the chat box, you star it when you have a solution, but you keep on working, and we share it over the microphone.